Section 1.2, Math 110. There are three terms that we use on this section. One is, let's look at this, they call it conditional equation. What type of equation is that? Let's look at these problems. X minus 5 is equal to 3. When you solve this equation, X is 8. How do I know whether X equal 8 is correct or not? Anytime you want to see if the answer is correct or not, you have to check. How do I check? You take 8 and you substitute for X. And then you see 8 minus 5 is 3. So this equation is true if and only if X is 8. So in the case there is an equation and you solve it and you come up with the answer, they call that conditional equation. Condition is X can only be 8. So there is a value that would satisfy that equation. On this example, when I want to solve this, 2x and 2x cancel, I end up having something like minus 4 equal to 1, and I know it's not true. Minus 4 and 1 are two different numbers. They cannot be correct. In this case, this equation does not have any solution. You cannot find any x, and you come up with something which is not logically true. So this type of equation, they call it contradictions, and it's false for every value of x. You cannot find any value of x that satisfies this. So they call it contradictions. Now let's get this one. Both sides are the same. So if I want to solve this, is like 0 equal to 0, or I see both sides are equal. So here, if I take any number and substitute for x, both sides are always equal. So there are so many numbers you could fit in. Every single number that you select for x and substitute, it works because both sides are always turn out to be equal. This type of equation is true for every real number of x. And the answer is, what's the answer for this? All real numbers. They call it identity equations. So you either have infinite answers, no answer, one answer. Now, based on that, we have some homework problems. One is, on this one, first I go ahead and distribute -7. Now, what I do is first you need to simplify each side before you start moving. Like here I have 42 and 4 is 46. So you do that first. Now, is it -7x larger than -4x or -4x is larger? You know, on the number line, if you remember, number line was a straight line and there was a point at 0 and the number as they go to the right, they increase it, go to the left, they decrease. Where is -4 and -7? If this is -7, -4 is here. So -4 is larger than -7. See, in that case, I move -7 to that side. So -7 become +7. And I want to collect all the numbers on this side. So +8 is -8. So when you solve it, x is 38/3. This is conditional. Why? Because you come up with the answer. Next problems. See, you have 7x and 8x. Which one is larger? 8x. So I move 7x to that side. That becomes -7x. +6, you move it here is -6. So x is 15. It's conditional because you come up with the answers. Now here we want you to solve and check. Okay. 7y. On this side, there are 2y. First, I simplify this. 8 and 6 is 14. Now I have 14y and 7y. Is 7y larger than 14y? No, 14y is larger. So I move 7y to this side and -7 to that side. So that would be 12/7, which is conditional. These problems, again, you end up with something which is not true. Is -12 equal to 3? No. So there is no solution. This is contradictions. So when you distribute this, 1x, when you don't see any number, is what? 1x. 1x minus 9x is minus x. You see, minus x and minus x cancel, and you come up with something which is not true. This is a case that both sides are actually the same. You know, when you multiply this, what do you get? 6x minus 10, right? What is 6x plus 3x? 9x. See, both sides are the same. In that case, remember, if both sides are equal, then all numbers work. So all real numbers, or they call it identity. What's the solution? All real number. Any value of x, when you substitute, both sides would be equal because both sides are equal. Now, if you have two fractions, let's say you have half, and here you have 3/6. How do I know these two fractions are equal? One method is they call it cross product or cross multiplications. So 6 times 1, or numerator of the first one times denominator of the second one, is 2 times 3 is 6. So if you have two fractions equal to each other, cross multiplication is this: a times d is b times c, or b times c equal to 8. So we use that one here. Three times that is 2 times that. And then when you do the distributions, you could find the x. So this is the conditional, because you could actually come up with a number. So we are using this property. Now, when you're solving the fractional equations are equations that has a denominator with the x. Problem like this, before you solve it, first you want to see what number would make the denominator 0. 2 and 6. When you solve the equation at the end, you must exclude these two answers. Why these two answers? Let's say if you solve the problem and you end up having 6, when you want to check, when you put here 6, 6 minus 6 is 0. The whole thing is 0. 4 over 0 is undefined. So for fractional problem is problem that has x at the denominator. At the beginning, you must exclude numbers that would make the denominator 0. Okay? So now the best way to do this problem, one method is your common denominator is x minus 6 times x minus 2, right? I would multiply each fraction by that, by this. So I can get rid of the denominator. See? I multiply each fraction by x minus 6 times x minus 2. In that case, what do you have? You don't have any more denominator. Now you solve the problems and you end up having x equals 6. Although the solution is correct, you cannot accept these answers. And I'll show you how. Let's say I didn't know that, and I'll check. Look what happened when you check. When you put 6 here, 4 over 0, it doesn't give you a number, it's undefined. So any number would make the denominator 0, you don't want that. So this problem has no solution because one of the answers happened to be that. Same thing for these problems, okay? From the beginning, we must exclude 0 and 3 because 3 would make this one 0 and 0 would make that 0. For that, we use the first method of factoring. They both have x in common. I factor x out. So what is the common denominator? X times x minus 3. I multiply each fraction by that. That helped me to get rid of the denominator. X equals 3. Do I accept that? No, because one of the conditions is you cannot accept 3. So no solution. And we have a problem like that here too. The very last one, look. From the beginning, we got to exclude this two, right? But x2 minus 25, we have a factoring formula that if you have difference of two perfect square is a conjugate, you could always break it like this. So 25 is 5 to power of 2. What is x2 minus 5 to power of 2? X minus 5 times x plus 5. So what is your common denominator? X minus 5 times x plus 5. You multiply every fraction by that. X equal 8. I accept that. Why? Because it's not one of these two. You could always pause your video if you want to copy or if you want to make a note, but you already have a copy of this. Next is how to find the x and y-intercept. The formula is this. If we ask you to find the y-intercept, we get a set 0 for x and find the y, and vice versa. 0 for y, find the x to find x-intercept. So what I did here, first I put 0 here for x. So minus 6 times 0 is gone. Y is 28. So this is what? Y-intercept, right? Look, when I plotted, where is it? It's on y-axis. So this is y-intercept. And then to find the other one, you put 0 for y and solve it for x. X is 14 over 3, which is like, what, 4 point something? You could plot it here. See, that is the x-intercept. So this is a formula for x and y-intercept. Put 0 for x, find the y, 0 for y, find the x. We do the same thing here. See? You put 0 here, this is gone. So y is 16, and then you put 0 for y, this is gone. X equal to 8. Okay, that's how to find the x and y-intercept. Again, we are using this rule here. Okay, that's the end of 1.2.